39, two elevators, A, B. 39, two elevators, A and B, move at constant speed. Elevator B moves with twice the speed of elevator A. Elevator B weighs twice as much as elevator A. And compared to the power needed to lift elevator A, the power needed to lift elevator B is the same, twice as great, half as great, or 4 times as great. Okay, so let's jot down some things that we know about elevator A and elevator B. We have, they both move at constant speed, right? But elevator B is twice as fast. So A has a particular velocity, and B has a particular velocity that's double that of A. So if we call this V sub A, velocity B is 2 times V sub A, right? It moves twice as fast, so it's double the velocity of A. What else can we say? Elevator B weighs twice as much as elevator A. So if we call the weight of elevator A WA, then the weight of elevator B is equal to twice the weight of elevator A. Okay, so we're just jotting down some things that we know. What do they want to know? They want to know, compared to the power needed to lift elevator A, the power needed to lift elevator B is what? Well, what is power? Power is the amount of work that's done over a period of time. So it's work per unit time. And what is work? Well, work is a force over a distance. So each of these elevators requires a certain amount of force to cover a certain distance in a certain amount of time. So we can write power expressions for each of these two elevators. So let's start with elevator A. The power for elevator A is the force. So what is the force that it has to use? Well, it's moving at constant velocity. So it doesn't have to accelerate the cars. It just has to overcome their weight. So this car has a weight of A. So the force that it has to use to overcome that weight, we'll call it force A. Or we could even use WA here because it's the same magnitude, but we'll call it force A. And the distance, we don't really know how far the elevators have to go, but we don't know for A or for B, so we should just assume they're the same, that they have to cover the same distance. So we'll just call that D, and we won't bother to use a subscript as to whether it's distance A or distance B, because they're going to be the same. And how much time will it take to do it? Well, the velocity of A corresponds to a particular time. So if it's moving with this speed, then it'll do it in a certain amount of time. So we'll call it time A. And by the way, if velocity A is only half as big as velocity B, then what would that mean for time A as compared to time B? Time A is going to be twice as big as time B because it's going half as fast. So time B is 1/2 time A. So that's basically saying the same thing. Something that's moving half as fast is going to take twice as much time, right? So now we can write the power expression for elevator B. Well, elevator B has to overcome the weight of the elevator B, which is 2 times the weight of elevator A. So instead of writing FB here, I'm going to write 2FA. Right? It's got to overcome twice as much weight because elevator B is heavier. And then the distance is again is the same. And the time, since it's going twice as fast, it's only going to take half as much time as A. So instead of writing TB, I'll write 1/2 TA. 1/2 of time A. So now if we take this expression and take those constants out front, we can rewrite this as 4 times FA times D times TA. So it's 2/2 is 4, and then everything else in this expression, this whole thing here, is equal to F sub A D T sub A is exactly the same as the power of elevator A. So one more substitution and we can say PB, power to operate elevator B, is 4 times the power to operate elevator A. So compared to the power needed to lift elevator A, the power needed to lift elevator B is 4 times as great. And we did that, in a strictly algebraic way. But if you want to just kind of check it intuitively, you can say, hey, elevator B weighs twice as much. So it seems like you would need twice as much power to lift something that's twice as heavy. And then elevator B goes twice as fast. So you're going to have to lift something that's twice as heavy in half as much time. So if you have to do it even faster, that's yet another doubling effect. So you have to double it twice, and that's how elevator B gets to be 4 times as great on the power that it requires compared to elevator A.